Welcome to this comprehensive overview of the AWS cloud concepts, which serves as the fundamental bird's-eye view for anyone entering the cloud ecosystem. This session is designed to walk you through the blueprint for a new foundation, moving away from the rigid structures of traditional IT and toward the fluid possibilities of the cloud. On the left of this slide, you see the old foundation, characterized by a chaotic mess of physical servers and tangled wiring, representing the complexity and physical limitations of legacy data centers. On the right, we see the new foundation, a clean, centralized, and interconnected cloud model that empowers innovation. For those preparing for the AWS Certified Cloud Practitioner exam, please note that this Domain 1, Cloud Concepts, accounts for approximately 24% to 26% of your total test material. It is the most critical area for understanding the core value proposition, economic benefits, and primary design principles that define how AWS operates. By the end of this presentation, you will understand how to transition from maintaining physical hardware to orchestrating global infrastructure with a few clicks. Before we can appreciate the power of the cloud, we must understand the heavy limitations that previously hindered business agility and innovation. In the old foundation, building IT infrastructure was defined by four primary constraints. The first is high capital expenditure, CapEx, which required massive upfront investments in physical hardware and data centers before any actual business value could be realized. You were essentially paying for the potential of success before you even launched your product. The second constraint is capacity guesswork. In a traditional model, businesses were forced to predict future needs months or years in advance. This often led to two failures: wasted, idle resources from over-provisioning, or performance bottlenecks from under-provisioning. Third, we faced slow procurement and deployment, where getting new resources was a manual process that could take weeks or months, effectively stifling experimentation. Finally, there was the maintenance overhead, or what AWS calls undifferentiated heavy lifting. This diverted critical engineering resources to tasks like managing physical servers, cooling, and power, rather than focusing on building features for customers. To solve these constraints, we look toward the new model. Cloud computing is defined as the on-demand delivery of IT resources, including servers, storage, and databases, over the internet with pay-as-you-go pricing. Instead of the physical ownership of hardware, you access these resources from a network hosted by a cloud service provider, CSP, like AWS. This shifts the focus from physical maintenance to digital consumption. We also look to the NIST definition to solidify our understanding. This model is designed to enable ubiquitous, convenient, and rapid provisioning of resources with minimal management effort. In this environment, resources are not static objects you own, but rather utilities you rent. Whether you need one server or 10,000, the method of access remains the same: a simple request over the internet. This allows organizations to store and process data on remote servers rather than maintaining personal computers or local server rooms. AWS identifies 6 specific advantages that differentiate the cloud from traditional IT, and these are essential for the exam. 1. Trade capital expense for variable expense. Instead of heavy upfront CapEx, you pay only for what you consume, transforming your costs into variable operational expense, OpEx. 2. Benefit from massive economies of scale. Because AWS aggregates usage from hundreds of thousands of customers, they achieve lower pay-as-you-go prices and pass these savings directly to you. 3. Stop guessing capacity. You can eliminate waste and performance risks by scaling resources up or down automatically to meet actual demand. 4. Increase speed and agility. New IT resources can be provisioned in minutes, allowing your team to experiment and innovate faster. 5. Stop spending money running data centers. You can focus on your customers while AWS handles the undifferentiated heavy lifting, the physical racking, stacking, and powering of servers. 6. Go global in minutes. You can deploy applications in multiple regions around the world to ensure minimal latency for your end users, regardless of their location. To understand the financial shift, we use the total cost of ownership, TCO model. Think of on-premise costs like an iceberg. Above the water, you have the direct on-premise costs, which are visible and obvious: server hardware, software licenses, and data center space. However, the majority of the cost is submerged. These indirect or hidden on-premise costs include IT labor for maintenance, power and cooling, physical security, staff training, and network infrastructure. The cloud model, based on operational expense, OpEx, often reveals significant savings by eliminating these hidden costs. A key part of managing this is right-sizing, which is the practice of matching your cloud resources to your workload requirements as accurately as possible. This ensures you are not paying for more than you need, effectively reducing waste while optimizing performance. By comparing direct and indirect costs through TCO, organizations can make a strategic case for cloud adoption. AWS categorizes cloud usage based on the level of management and flexibility you require through 3 primary service models. Infrastructure as a Service, IaaS. This is the do-it-yourself kit. It offers the basic building blocks like networking, compute, and storage. While AWS manages the physical hardware, you manage the most, including the OS, data, and applications. It provides the highest level of management flexibility. Platform as a Service, PaaS, known as the ready-to-bake kit. This model removes the need to manage the underlying hardware and OS. This allows you to focus solely on deploying and managing your applications. Software as a Service, SaaS. This is a fully prepared meal. It provides a complete product that is run and managed entirely by the service provider. You simply use the software, such as web-based email, and you manage nothing of the underlying infrastructure. To help visualize these models, think of cloud computing like the evolution of transportation. On-premise is like owning a fleet of buses. You are responsible for everything: the vehicles, the garage, the mechanics, the drivers, the fuel, and the routes. This requires high CapEx and full control. IaaS is like leasing the buses. You lease the vehicles but hire your own drivers and plan the routes. You don't own the core asset, but you control the operations. PaaS is like hiring a bus service. They provide the bus and the driver. You just decide who gets on and where it goes, managing the passengers and the destination. SaaS is like taking a taxi or using a rideshare app. The entire journey is managed for you, and you simply pay for the specific trip you take, exactly when you need it. In addition to service models, you must choose a deployment model based on where your infrastructure resides. Public cloud, cloud native. This is the most common model where all workloads and infrastructure reside within the CSP's environment. This allows for the maximum benefit from cloud advantages. Private cloud, on-premise. Here, resources are deployed on-site using virtualization and resource management tools like OpenStack. This mimics a cloud environment, but is for dedicated use by one organization. Hybrid cloud. This acts as a bridge connecting on-premise data centers, or a private cloud, with the public cloud. This allows data and applications to be shared between the two environments. Multi-cloud. This involves the simultaneous use of multiple public cloud providers. Organizations use this to leverage specific services, avoid vendor lock-in, or enhance overall resilience. Building in the cloud is more than just turning on servers. It's about quality design. AWS provides the AWS well-architected framework, a set of best practices for designing and operating reliable, secure, efficient, and cost-effective systems. Instead of guessing how to build, you follow a proven blueprint. These practices are organized into 6 conceptual pillars. By aligning your architecture with these pillars, you ensure that your foundation is strong enough to support the growth of your business without collapsing under the weight of technical debt or security vulnerabilities. This framework helps architects democratize advanced technologies and adopt consumption-based financial models. Let's examine the specific focuses of the 6 pillars. 1. Operational excellence focuses on running and monitoring systems to deliver business value and includes the concept of operations as code. 2. Security focuses on protecting data, systems, and assets while emphasizing strong identity foundations and the principle of least privilege, POLP. 3. Reliability. Focuses on the ability of a system to recover from failures, dynamically acquire resources, and utilize horizontal scaling to maintain availability. 4. Performance efficiency. Focuses on using computing resources efficiently to meet requirements, often by using serverless architectures. 5. Cost optimization. Focuses on avoiding unneeded costs, understanding spending, and adopting a consumption model. 6. Sustainability. The newest pillar, focusing on minimizing environmental impacts through energy efficiency and carbon reduction. A successful cloud journey involves more than just technology. It requires a shift in the entire organization. The AWS Cloud Adoption Framework, CAF, provides guidance to help organizations update their skills and processes. It organizes migration guidance into 6 perspectives. Business, aligning it with business goals. People, managing people and organizational change. Governance, managing portfolios, programs, and assets. Platform, designing and building the cloud platform. Security, meeting security objectives during the transition. Operations, managing and operating the new cloud environment. By following the CAF, companies can optimize the value of their transition and ensure all stakeholders are aligned. In summary, the shift to the cloud is a strategic move away from the old constraints of capital expense, capacity guesswork, and slow deployment. We have explored the new foundation built on agility, global scale, and operational efficiency. By leveraging proven economic models, clear service architectures, and best practice frameworks like the well-architected pillars and the CAF, organizations can stop managing infrastructure and start building the future for their customers. As you move forward in your studies, remember that the cloud is not just a place to put your servers, it is a foundation for innovation. It provides the pillars of operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability to support your growth. This concludes our deep dive into Domain 1. By mastering these core concepts, you have laid the first stone in your own foundation of AWS expertise.